So, hello everyone. I'm Armand Varteressian and here is Mathys Lopez. And so for the last 2 months, we've studied the performances of a gloss scanner on colored and non-flat surfaces.
So first of all, it would be cool to define what gloss is. So gloss is a sensation of the eye, which is, it detects how the surfaces react to light, how it reflects light. For example, we'll consider a surface glossy, really glossy, if it acts like a mirror. And on the contrary, we'll consider a surface matte if it looks like this, the car, for example. And here on the left, we have two examples of levels that we studied. So we've at first on the top a glossy level, and on the bottom quite a matte level.
So what is the origin of gloss? So the origin of gloss is the roughness of the surface. So if we have, for example, a smooth surface, we have the light coming from one direction that will be reflected in only one direction. So like a mirror, so we will have a glossy aspect. And on the contrary, with a rough surface, we'll have the light coming from one direction that will be scattered on all the space by the rough surface, so we will have a matte aspect.
Nowadays, we measure gloss with glossimeter. It's an instrument that will compare an incident light with the reflecting beam of light at a fixed angle. This instrument can have a different determined angle. For example, we used one with 3 different angles, one at 20 degrees from the normal, 60 and another at 85 degrees. But this instrument has limits. The first one, there is a determined, there is a fixed number of angles. So it's the first limit. And the second one, it's the fact that it will give an approximate value of gloss unit for wall surfaces. For example, for my wall hand, it will give the one gloss value, but we can see that there is not the same gloss value for every surface of my hand.
So that's why we used a gloss meter. So a gloss meter is composed of a light source on that is on an axis that we will move, and of a camera. And so the point of the experiment is to move the light source along the axis. And for each position of the light source, we will take a picture with the camera of the sample. And so at the end of the experiment, we'll look at each point of the sample, and we will look at the reflected light, as the light reflected by this sample for in function of each position of the light source on the axis. And so we will deduce a curve like this. And so with this curve, we will deduce the gloss value of the point. So if the curve is very narrow, it means that the light is coming from, that the light reflected is coming from only one direction. So the surface is glossy. And if the curve is very broad, it means that the light is coming from all the space, and so the surface is matte.
Here are some of our results. So it appears a bit messy, but here we can see for each curve there is a point linked to it. So it's what was talking about Armand. And in our results, we detect some problems, some issues. One of them is a bit visible in this result. It's the saturation of the curves. Because of this saturation, we have and we underestimate the values. We have a problem of values. We are not accurate of for the gloss unit of the point of the pixel. And another problem that which is not shown here is the dependence of color and of the dependence of gloss and color interdependence, because for two samples with the same gloss unit theoretically, if they have a different color, it will not appear the same. It will not have the same glossiness.
So even if our value of gloss unit are not very reliable in absolute, we can still use our gloss meter to compare laser like this and have a resolution that is better than the human eye. And so with our gloss meter, we also keep a form of proportionality between the gloss value of our lasers and what we will expect.
Of course, it's a first experiment. This system can be improved, and it will meet, we think, a lot of application in, for example, in cosmetics, and more often more particularly in fashion, because to master gloss and to master matte is something really difficult, and it's a challenge nowadays to really understand it and measure it, and so to control it. So thank you for your attention.